Hello. It's already a long time that I've been interested in Kafka. I've been reading about it, but only until recently I had the time to really dig into it and explore it and play with it. And there is a lot of hype around Kafka, but I have to tell you, I believe it's legit, it's justified. I'm a cautious person. I like to do my own research. I don't just trust, whatever um, an interested party says about technology X being the greatest thing since cloud computing or some nonsense like that. So I've done my homework. I've been reading mainly these three books, which I totally recommend, and they are on the post that I wrote. But more importantly, I also got my hands dirty and I coded against Kafka using the Kafka APIs. So what is so special about Kafka? So first of all, it's an amazing piece of software. Its scalability and availability is amazing. It has been built from the ground up with the most demanding use case in mind. But the second thing, which is more important, I guess, is that leveraging Kafka, we are able to rethink the way we have been designing distributed computing systems. And this is something revolutionary. Okay, so let's talk about this proof of concept application that I've been working on. So the code is available on GitHub, these two repositories. And let me show you the entity object. So this is the account balance entity. And the main fields are the balance, which is the amount available in that account. And then we have, of course, the account ID and then the transfer ID. The transfer ID identifies the latest transfer or transaction that has been applied to this account. So if we open the transfer entity, we see that it has the ID, the account ID on which we need to apply this change, and then the amount. So for instance, if the amount, let's say it's $20, it means that we need to add $20 to the available balance of the account identified by this account ID. Here we have a diagram of this proof of concept application. We can see that it all starts with messages being written to the transfers topic. They represent, money that needs to be added or subtracted from an account. So the account balances are represented by messages in a different Kafka topic, the account balances topic. And whenever we receive a transfers message, we need to find the related data for the account balance, to which that transfer message refers to. So the Streams API creates and maintains a local data store, which is a materialized view of the Kafka topic. This is very important. You see, this is we don't need to do anything about it. The materialized view gets updated with every single message which arrives to the account balances topic. But we don't even work at that level of abstraction. We work at a higher level of abstraction because on top of this materialized view, Kafka Streams create a K table, a Kafka table, which we can join with a stream, a Kafka stream, which represents the topic. So once we have those two sets of data joined by the account ID, then we can create a new account balance message which represents the updated balance for that account. Let's see how all of this is implemented in the code. So here we have the transfers Kafka stream. We can see here, right? And then we have the account balances Kafka table, right? Which is backed by the materialized view, which it's ultimately, source the data from the account balances topic. And then we create a new Kafka stream, which ultimately we will, redirect to a topic, to the same account balances topic. And just saying that we want to join this string with that table, and the Kafka Streams API is smart enough to know that it needs to look for the account balances ID, which matches the account ID specified in the incoming transfer message. So then we also pass a joiner function. Here we have it. And we can see that here we specify what we want to do with the transfer message and the account balance message. So we just call the business logic, right? Here we have it. New account balance provider, provide, right? So here we have it, and it's as simple as we get the current balance and we add the transfer amount. So this can be negative, so actually the balance may get reduced. And also we increase the version. The version in the account balance object tell us how many transfers have been applied to that account, how many times the balance has changed. Let's go back to the main code, because I want to highlight that there are no request responses here. Everything is event driven, right? So a message is received, and then we enrich the data with the data, from the materialized view. The materialized view gets updated whenever an account balance is received. So that's again event driven. We don't need to send a request to a remote database to fetch data. No, the data, it's right there in the same memory space as our Java code. So this is a great advantage. And one more thing, this is a clear example of CQRS, Command Query Responsibility Segregation. Because if this was a regular application, or non-CQRS, then once I have updated the balance, I will just store it in the same database. I would just override the record. But here, the paths of reading the balance and updating the balance are totally separated. You see, we receive a message, we materialize it. The materialized view, it's our read database. But then once we have updated the balance, we create a new message. We don't override the existing message, but we create a new one, and this is the path. So it's a different path. And yet one more thing before we run the code and see the application in action. Please note that this is not an example of event sourcing. If we had applied event sourcing, this topic wouldn't be here. This account balances topic wouldn't exist, because we will only have the transfer topic, and then in order to know what is the current balance, we would need to go through all the messages stored in the transfers topic and apply those changes on the fly. Calculate the balance on the fly every time. So of course this comes with its own set of issues, mainly performance issues, even though Kafka allows for snapshots. But you know what happens when messages are being deleted from the topic, even though in theory you could store the messages forever in a topic, and it could grow endlessly, but it's not very feasible. So another option, we could actually create one topic per each entity. In this case, one topic per each account ID, but that's also not recommended by Kafka. It's not a good practice to create so many topics. So yeah, I decided to create these account balances, also because we are talking about money here, right? I mean, Kafka started, the original use case was to handle monitoring data and usage data, like for instance answering questions like how many users click on this specific website back at the LinkedIn during the last 10 minutes and things like that. But then what people have realized is that the same stream processing techniques can be applied to build regular CRUD applications such as this one. So in short, this is not event sourcing, and that's why also in the account balances entity, here we have it, we have a version, right? Because as I said, this is not about clicks, that it doesn't really matter if you measure 253,000 clicks or 253,020 clicks, right? But with money, every single cent counts. So that's why I decided to add this version field in the account balance entity, so we are sure that we don't miss any balance update, any transfer. And if we actually see two account balance messages for the same account ID and the same version, we know that we have an issue. We can see clearly, we can spot that there was a conflict, that there was a concurrency issue. Okay, so let's run the proof of concept application. But before that, we need a Kafka broker up and running. So I decided to download and install the Confluent platform, because in addition to Kafka, it also includes very useful components such as pre-configured integration with Elasticsearch and Kibana. It also has an embedded relational database which can be used as source using the Connect API for Kafka. But more importantly, it also includes an admin web UI called Control Center, which is very useful to see what's going on your Kafka broker. But yeah, I have to actually perform a few steps that were not included in the documentation of Confluent platform. For example, I have to install a couple of packages, and then well, I had to separately install the Confluent CLI, but that was mentioned in the documentation. And also, actually, I had to modify some properties files. You can see here, to be able to run Kafka, the Confluent platform, using a non-privileged, non-root account. So everything is detailed on the blog post, and the link to that blog post is included in the description of this video. I also included some environment variables according to my environment. So if you do the same, of course, change it according to your local environment. So let's start it, and let's start first Elasticsearch, which I have to install separately, as well as Kibana. So here it is. Elasticsearch is coming up. Let's move to starting Kibana. There it goes. Okay. So now we are ready to start the Confluent platform. You see several components. And yeah, this is gonna take a while, so I'm gonna stop now and we'll continue in a couple of minutes. So we can see that the Confluent platform, it's already up and running. They actually included an example application. We can see that they created some messages that they posted to the topics. You see, this is like an order or a product entity, customer ID, and so on. And we can see this data that was fed into the Kafka topics. We can see it, for instance, visualize it on Kibana. As I said, they have already integrated Kafka with Kibana. So products by count, another visualization here. Then we can also see the raw messages. Here we have it. Yeah, but more importantly, the Confluent platform also provides a web admin UI, which is called Control Center. Here we can see that we have one healthy cluster. So we go and we can see the topics. You see many example topics. And I need to create a couple of topics for my application. So I'm gonna add one of them. It's gonna be called transfers. Okay, so number of partitions, 1. I'm gonna customize the settings. Availability, the lowest, because this is just a proof of concept. Cleanup policy, compact, because I wanna keep at least the latest message per key. So 1 week retention, okay, and save and create. And I'm gonna, well, we can see that actually there are no messages here. If I go to the offset number 0, nothing comes up. So I'm gonna create the second topic, okay? So it's gonna be called account balances. Oh, sorry, I'm not typing. Account balances. Okay, same settings as before. Okay, the lowest availability, and save and create. Okay, again, this topic is empty, right? So now I want to initialize my accounts. I'm gonna use 2 different bank accounts, and I'm gonna send transfers to both bank accounts, and I'm gonna see how the state changes and how the application works, and everything is gonna be event driven. Okay, so it's time to run my POC application. I actually implemented it twice. Once using the low-level consumer and producer API, and then the local data store. So here we have it. It implements this interface, and we can see, because it uses this transfer consumer, that I'm explicitly polling for new transfer messages. And then we have the other implementation, which is the one which is based 100% in the Kafka Streams API. You see that it implements the same interface and there is no explicit polling here. It's all abstracted away and we are working at a higher level of abstraction. So let me start the streams implementation of the transfer recording service application. Here we have it, join mode. So it already started. I mean, the main thread exit, but we have the background streams thread running. And now I'm gonna initialize the two bank accounts to which I'm gonna apply transfers of money, right? I'm gonna reduce and increase the balance of those bank accounts. But first, I need to kind of create those bank accounts. So for doing that, I'm gonna send two account balances. So I have run configuration for that. You see, transfer recording service tester initialize. What this does is just send two messages. Here we have it. Transfer ID is initial because we are just basically saying that, okay, this account ID is valid and it has been created. And the balance obviously is 0 and the version is 0. Okay, so if we go actually to the control center, we can see we need to go to the offset number 0 and we see those two messages, right? You see, this is one account ID, the second one, the offset is 1, and this is the first one, offset 0. Now we are ready to perform the real test, which means we are gonna send transfer messages and we should see how the account balances changes accordingly. So I'm gonna execute it right now, send transfers. Here it is, done, it already sent the messages. And now we go back to control center. Let's see first the transfer messages. So we go to transfers topic, messages, we go to offset number 0. And here we see that we have 1, 2, 3, 4, 5, 6, 7 messages, right? So the offsets go from 0 to 6. And the first message here, we have sent a transfer which represents 30.75 US dollars or euros, whatever currency unit. Because we see this is the scale. So it means that from these 4 digits, 2 are decimals. So this is for account 1. Then for the same account number 1, we have sent +5, then -783, but we need to take into account 2 decimals, so that would be -7.83. And then to show that we can use an arbitrary number of decimals, we have sent, this is 5 decimals, 11.00005, right? So we can actually see it here. So account of 1 plus 3075 plus 5 minus 7.83 and so on. So we should have version 4, 1, 2, 3, 4, 4 transfers. The version gets incremented with each transfer message So total version 4. And for account 2, similarly, only 3 messages, and this is the total, version 3. So now we should see the same thing on the account balances. So if I go to the account balances topic, here we have it, messages, offset number 0. You see, here are the offsets. We can see how the balances changes. Again, with each incoming transfer, we generate a new account balance message. So everything is audited, right? So let's look at it this way. So this is the latest account balance for account ID 01. So we see that it's 38.92005, and that actually matches what we expected, right? Version 4, version 4, so correct. And for the account number 2, the latest account balance is 68.17, because the scale is 2 and version is 3, right? Yeah, that's correct. It matches what we expected. So going back to the Control Center Web UI, to the account balances topic, let's look at the latest message. So we already saw that the balance amount matches what it was expected, but we also see the transfer ID 10469 and so on. So we can see that this should be the latest transfer applied to this account ID. So let's go to the transfers topic. Here it is, messages, offset 0, and let's have a look at it. And exactly, you see ID 10469, and we can see that we increase the amount to 110005. So exactly what it was expected. This is the latest message. So everything works as expected, but I have to be honest with you, I kind of cheated a little because I added this sleep statements for 300 milliseconds, 200 milliseconds, you know, in between sending a couple of messages. So I'm gonna comment out these sleep statements and let's see what happens, okay? So these transfer messages will be sent and arrive, you know, almost simultaneously. Okay, so after commenting out the sleep statements, I have restarted the Confluent platform. I have initialized the 2 accounts by sending these 2 initialization messages as before. Now I'm gonna start my application again because I also had stopped it. Again, join streams mode. Okay, it's already up. And now I'm gonna perform the test again, but this time, remember, without sleep statements. So here we have it. Send transfers. And now you see that the messages are being sent, you know, with very little delay. Okay, let's go back to the web UI. So let's go to the transfer messages first. So transfers offset 0. And we see, as before, we have 7 messages, but the timestamp, you see, they are very, very similar. Just 1 millisecond, right? Then 3 milliseconds, another 3 milliseconds. So this is, you know, very concurrent, almost concurrent, right? So let's go back now to the account balances topic. So account balances. We see the messages offset 0. And let's have a detailed look at the latest message. And you see that it's wrong. You see? First of all, this is not the current value, the correct value. You see, we should have this value, but we have this value. And the problem is that we have skipped the processing of these 3 messages, the previous 3 messages. Because you see, the version is 1, right? If we see the application logs, here it is, my application logs, you know, you see that the messages were gathered almost at the same time. Because Kafka, in order to improve performance, doesn't grab a message one by one. It grabs a set of messages, and that's configurable. But we are using just the default configuration. To see it better, let's have a look again at the diagram. Here it is. This is the problem, right? We are creating a message, but before this new message arrives to the Kafka topic and gets materialized into the read-only view, we are already processing the second one, the second transfer, and even the third one. So this is the issue, right? So how do we fix this problem now that we have identified what's the root cause? So we can do several things. We could, instead of allowing here to get the transfer messages in batches, let's say 10 messages, 20 messages, we could play with the commit, because now we are doing auto commit. Commit is when you say, Kafka, hey, okay, I'm done processing those messages, and I'm gonna get new messages from the topic. So we could get the transfers one by one, right? But that wouldn't be very effective, because the issue is when the messages, the consecutive messages, belong to the same account ID. So transfer messages which refer to different account ID, they can be processed concurrently, right? Or when I mean concurrently, I mean on the same batch, right? The problem is messages, transfer messages which belong to the same account balance. So we could also maybe here in the external writer delay sending a message if, you know, it's too close in time from the previous account balance message. It also has its own set of issues, you know, sometimes you cannot control the clients, but yeah, it could be done, right? In this way, you know, we only wanna slow down the messages belonging to the same account ID. Or here we could put some logic here and increase the complexity. And we could, on top of this materialized view, we could have some kind of map. So if we know that in the current set of messages that we have received from the transfers topic, we already have a transfer which refers to account ID, and then we get a second message on the same batch which refers to the same account ID. We could, slow down the process until we see the previous message in the materialized view. We will commit, send, and then wait. So yeah, it's not an easy task. I'm gonna think about it in a later video probably. I will show you the possible ways to fix this. But again, this is at the application level. This is very important. You are the application developer. You should be aware of your domain, because this is related, tightly coupled to your domain. Okay, this video ended up being longer than I expected, but I hope you didn't get too bored, and thanks for watching.